Okay, what is this? This is a bioreactor using algae. I put, you might be able to see by shifting a little bit away, I have this solution which consists of potassium ferrocyanide, potassium nitrate, sodium formate, a few grams of that, a few grams of iron, a few grams of ETA, shell-tape the solution, and I have also ammonia, triammonia phosphate and other material, and diluting it by a factor of 10. So on if you can see right over here, and zoom in a little bit. If you can see right here with the 10 sample where the 1 millimeter is and the 1 millimeter is here, I put in about that much of the sample into here, but I filled it up to the top to the 7 to 8 marker point where the bottle is, and that will create algae over a long period of time. This is what the algae is. It's plankton, but it's still considered a form of algae. So that's what I'm going to call it. And I have this light here that's pretty potent. Can you see that? But the light itself can move and twist different angles. So it's very handy for what I need it for. I can just bring it down a notch to give it more light. And what I'm looking to get is a light meter to determine how much light the algae are getting when I grow them. And a salt meter to determine how much salt it is. Maybe I don't have a salt meter, and they recommend not doing this blindly without a salt meter because you might not have the right concentration of salt. It must be 1 milligram, 1.019 grams salt per milliliter sample, and that's about the average of a neutral salt solution, just a regular salt solution in the body or that kind of stuff. So that's what you have to have for this to work. And if I go in and zoom in closer, and we can see this mirror is bouncing out the light at the bottles to try to get them to grow faster. I'd say, what's the point of just using the aluminum foil on top of the hot plate? Because then it just reflects the surface. If I have a mirror or several mirrors here, I could reflect and increase the concentration of light that's going towards the algae bottles, but I can't. So what I have to do is a long period of time, grow them, maybe even weigh out the bottles, or even look at the algae underneath this microscope. This is a microscope that I use. It goes up to 1,000 times magnification. It works quite well, even though it's a bit dirty on some parts. I need to clean it, but I might need to replace some lenses in the future. But what I'm saying is, I have all the equipment needed to grow and detect algae. I even have the nitrogen tests, which have been tested at 500 parts per million when I had another sample, full concentration. But this is 1/10. This would be like 5 or something like that. 1/100, 1/10. So it'd be about 50, roughly 50 parts per million nitrogen in there. If I tested it, it would be that too. So what I'm doing right now is I'm trying to figure out how I can make this work better. I'm giving it two pumps. You might not be able to see this, but 2 pumps here. 2 pumps to give it extra air, and I'm doing this so it's a low type of material. And the algae, I might do projects where I expose algae in test tubes to electromagnetic radiation or some form of electromagnetic radiation in the future, because the bottle's electromagnetic radiation can penetrate where radiation and other stuff won't be able to. So I might have to buy a high voltage transformer for future projects. And you know, water and electricity does not mix very well, very dangerous.